Hello and welcome everyone. Welcome to what I hope will be a small series of videos on spectroscopy. In this first video, we'll see some basic facts and show the setup that I will use in future videos for some demonstrations and measurements. Let's start with radiation. Radiation is everywhere in the universe. Radio waves, X-rays, microwaves, starlight and sunlight are all manifestations of radiation. Now, light is a particular case because our eyes are sensitive to light by recognizing color. For instance, this is a regular laser pointer. We can see it's red. Now, this color red can be very precisely measured. And because radiations are electromagnetic waves, the color is measured in wavelengths, usually nanometers, billionth of a meter. So different colors, different wavelengths. Now, spectroscopy is the study of the interaction of radiation with matter related to that radiation's wavelength. That relationship is called a spectrum. Let me show you a spectrum. So this is a spectrum. You can see on the horizontal axis, the wavelength, and the vertical axis, the intensity. This is what it looks like. So different colors, different intensities, good example of a spectrum. Now, people must have been quite curious about light and color since the beginning of time. But the history of spectroscopy seems to start with Isaac Newton's paper published in 1672, where he describes that sunlight going through a prism is made up of a mixture of all the colors of the rainbow. Let's try to reproduce this. Here's a prism, small prism, piece of paper, light source from this side. If I move the prism, you can see dispersion of light, and you can see some colors on the edges. Not easy to see, so I'll add a slit. Slit makes the source of light look smaller, so the dispersion is a little bit more obvious. Not much better, but you can see a little bit of blue and light and red. And let me show you a picture that I took earlier on today to show exactly what we're talking about. So the prism is here at the top, and the dispersed light shows the red on one side and blue on the other side. So this is what Newton did. After Newton, the 19th century saw numerous advancements in the field of spectroscopy. Among others, Joseph Fraunhofer refined the techniques for precisely measuring a spectrum. That's what he published in the early 19th century. You can see the spectrum with colors dispersed from red to blue, with lines in it. We'll see in a later video what these are. Showing the intensity with this curve here. He was looking at sunlight in this case. And this is the title at the bottom of his paper at the time. Fraunhofer is followed by Wheatstone, Foucault, Angstrom, Stokes, Kirchhoff, Wien, and Planck, all great scientists who contributed to our understanding of the relationship between radiation, intensity, wavelength, chemical composition, and physical condition. This is amazing now because with this information, we can figure out, for instance, from starlight, what is the chemical composition of a star? This is quite amazing, isn't it? Now let's talk about the measurement setup that I will use. Nowadays, prisms are not used much in instrumentation. they have been replaced by what is called a grating. A grating is a surface with parallel lines. I'm showing a CD here, and it's very similar. It has gazillions of lines very narrowly placed to each other. And this acts as a dispersive medium for light, therefore creating a spectrum, just like a super prism, if you like. You can make simple spectrometer with this CD or a DVD, and you can find that on the internet. I made one with a transparent grating a couple of years ago using a camera of mine. So the grating is here. There's a lens here and a slit, entrance slit, a diffuser for particular measurements. And then the result of the dispersion of light that comes from this side of the instrument goes through a lens and my camera. And in this case, the camera is used as an extra sensitive eye, if you like. I was hoping to be able to make measurements with this, but it turned out not to be very precise. So let me show you the kind of spectrum I got with my camera. Wasn't precise enough. So I decided to buy a used commercial spectrometer and its software from Ocean Optics. It's now called Ocean Insight, and mounted it on a plate. Let me show you that. Here's the spectrometer, small little box, you can hold in your hand. And it has a grating, 2 mirrors, and a small camera to read the spectrum. Powered by USB, the data is being read by USB as well. The entrance of the light is on with this little connector here, fiber optic connector. What I've done in this case is I've added a light, a source of light. Let me power up that source of light for you and turn off previous one. So this source of light will be used for transmission measurements. We'll put a filter here, what we want to measure with these alligator clips, and measure transmission of light here. If I want to measure reflection, I'll just move that light to the side like this, and the reflective surface will be installed here. Now, let me show you what a spectrum looks like with this software. Here we go. So this is the spectrum of the light that I am using in the setup. Again, you can see wavelength at the bottom, intensity on the vertical axis, and this responds very, very fast and is precise to just over 1 nanometer. And we'll be able to take measurements of tens of items that I have in the house, and that should be quite exciting. So that's it. Thank you for watching, and stay tuned for the next installments of this series, where we'll talk about emissions, transmissions, and then reflections. Thank you.